Hey everyone, today I want to talk about vector databases and their need for them. In the early days of the internet, most of the data that came into databases were highly structured and in table format. So it was very easy to query them. But with the advent of modern age, digitization of cameras and social media coming into play, we have seen an explosion of unstructured data like audio, video, text, and images. Now, how do you search for these data? Well, in the early days, what we started doing is we started associating metadata and tags to these pieces of information. Say, for instance, you have a video of a person playing baseball, we would say, or we would attach tags to it saying person, baseball, playing, and so on. And how we would categorize them is through clustering or text search of these metadata itself. And similarly, searching was also mainly done by looking up the metadata and the text associated with this data, unstructured data. And to give you an instance, in the year 2000, we produced about 1 exabyte of data, which is 1 billion gigabytes. By 2007, it was 281 exabytes. And if you see in 2010, we produced about 1.2 zettabytes, 2015 8.6, 2020 64.2, 2023 147, and it's predicted by 2025 you're going to produce 181 zettabytes, which I think we'll overshoot, and this prediction is highly conservative. A zettabyte is 1,000 petabytes. 1,000 petabytes, 1,000 terabytes is 1 petabyte, and so on. You get the picture. A lot of unstructured data. So what do? The solution right now is to put these unstructured data through a machine learning model and produce embeddings. And embeddings are basically just numbers in an array. So how does this help? Well, it becomes very easy to do mathematical operations on them. And what we do is we can find the similarity between two vectors very easily using different metrics of distances like Manhattan, Euclidean, cosine, and there's others also like Jaccard. It is a good read trying to figure out what is best suited to your needs, and actually you should definitely play around with these metrics to see what fits the purpose that you're trying to use them for. So how do you do that? So say an image, it has an embedding associated with it, and you want to search for images like that, you would put in your query, which would get transferred into another embedding, and then we would look up in the vector database through highly efficient indexing the similar ones, like top 10, top 100, and so on, and it would fetch those images which were the most similar to the one that you asked for and give you those results, right? So the use cases. Vector database helps with long-term memory problem of LLMs. For instance, you take a vector database and you put all the knowledge in it. Every time you ask a query, you can do something called retrieval augmented generation, which helps with the memory problem of large language models. Semantic search. What does that mean? So you can search by simply asking for what you want, saying that, hey, I want a picture of a dog playing with a ball, and so on. And it becomes easier to query them in a vector database of embeddings. Then, of course, the final one is similarity search. And this helps with powering recommendation systems where you say that, hey, this person viewed this item. Can you search for items which is similar to this image in your vector database and give suggestions like that to the person again? Now that's about vector databases. So let's take a look at a couple of examples of companies which offer them. So here's a list of them, Milvus, Quadrant, Pinecone, Vespa, Chroma, and more recently OpenAI, where I think they all acquired RocksetDB very recently, and they are offering it through their APIs, and I'll probably make a video on them very soon. Thanks everyone. This is Software in 5.